All right, so today we have the founders of Lamini, which you can read more about at lamini.ai. Sharon and Greg, welcome to the Data Exchange podcast.
Thanks so much, Ben. Thanks for having us.
All right, so the tagline is all in one stack for open LLMs at scale. And we'll dig deeper into what that means. But one of the main reasons I brought Sharon and Greg onto this podcast is they've done recent work with AMD, which I want to kind of explore further. So first, at a high level, what exactly did you guys do with AMD?
We are the only ones who've done this so far, who have put AMD machines in production to run, train, build your own large language model.
So it's includes pre-training, fine-tuning, and inference.
Correct. All of those things.
And so generally, Greg, what is the main takeaway in terms of AMD competitiveness, speed, all of that, cost? So what's the takeaway?
Well, it works. The hard thing about getting anything to work in this space, it's not building a fast accelerator. So before this, I co-founded MLPerf, which is a standard that measures performance of real machine learning workloads across everyone who is building a machine learning accelerator. And we've seen all of them. And one of the takeaways from that is that it's easy to build a really fast hardware, or it's not easy, but people have succeeded in building really fast hardware. But the thing that no one has really done historically, other than NVIDIA, is build a software stack that can run a real production application. And the thing I realized, and this was around 2020, I talked to all these companies. You know, I've had a relationship with AMD for more than 15 years. I talk to them very frequently. The thing that I realized is that everyone in the market kind of thinks that AMD software stack is like 10% of the way there. And at the time, it was more like 90% of the way there. So that's like vastly more, like they'd really put a lot into ROCm, but it wasn't 100% either. So like if you tried to build a real application, you run into tons of issues. So the thing that we realized is that the gap, like closing the 90% to 100%, was just much smaller than people realized. And we just went out and tried it. And I was just looking at this yesterday. We had like the first, we had one GPU, so an MI100. Was the first GPU we actually got a full application to run on, like the fine tuning, you know, the inference stack, like the actual like complete end-to-end application. It took a while to get that to work. Like there are many different pieces of the software stack, like the gem kernels, like matrix operations. There's the frameworks like PyTorch. There's the application layer of like, how do I serve all of these things? And, you know, how do I make these available? Like if I want a chat interface like ChatGPT, like how do I make that work? The MLPerf server scenario, like there's all of that stuff. And it took us about a year, I would say, just like, you know, small team of people, like just building out all of the missing pieces, filling in that like remaining 10%. And the biggest difference was just, you know, if you started from scratch, like imagine you started from scratch on like a new accelerator, even if that accelerator was able to run like one kernel really efficiently, we might have to write a driver. You know, the AMD Linux driver is 50 million lines of code. That's kind of a lot. I wouldn't have been able to do that in a year, but AMD has a, you know, open source 50 million lines of code Linux driver that they've been maintaining for 20 years. They came out of their ATI acquisition. Like there are a lot of these like hard low level pieces of the software stack that were there for AMD, even if no one had really like put all of it together into a complete application.
So Sharon, for listeners, what does this mean in terms of, so is Lamini the only place to use AMD for LLMs at the moment, or do you anticipate AMD will gain more users in 2024?
Oh yeah, that's a good question. I imagine, well, like my view on this is we're essentially like almost like a CUDA layer on on AMD. Obviously not as deep as CUDA right now since we're a startup, but essentially we're that layer. So I think of it as I think a ton more people run on AMD. It might be through Lamini. I think like we're just making it much easier for people to actually do that as if you were on top of CUDA, right? And even beyond that. And so I should hope that we will get many more customers who will then run a lot of those loads. And so that's what we're really excited about. And we already have, you know, a bunch of customers actually running in production on our AMD cloud. And I think what this means for the whole ecosystem is opening up an opportunity for another compute player. And so that definitely you know, it reduces the monopoly. So it's probably good for anyone developing an AI so that, you know, the costs will come down, availability will go up, and people will be unblocked from building applications. And I think that's one of the big motivators that we have. We want to make it possible for anyone to build their own large language model, right? At Lamini, we want you to be able to completely own and to customize super intelligence moving forward. But the only way to do that is powered by compute. And so with that being a blocker, it's not possible. So to make it possible here is our goal and mission, and this is one of the very big drivers of making that possible. So yeah, so our customers can go on now and actually have really large, you know, training jobs or compute jobs, inference jobs, and be able to succeed fully as if they were on NVIDIA. And so that's really exciting. And of course, our software does run on both AMD and NVIDIA. And makes it possible for people to port and be flexible as well across their clouds, across on-premise solutions, and across our cloud as well.
So, Greg, as you described it, so it wasn't exactly like a week's worth of work, right? So it took a while. You're a startup. So what is the genesis of this project? So in other words, so obviously as a startup, you could always have just used what other startups are using, which is NVIDIA hardware. Why invest so much man hours into making this work? Was it desperation? You had no access to NVIDIA chips?
It was huge desperation of not having access. That was my experience as a startup founder. Also previously like advising startups, working in startups. It went from a situation of, it was actually very different. So let me rewind back in time. Like back in 2005, so I worked on CUDA, we released CUDA. You could buy a GPU, like a gaming GPU for $500. You could just put it into a machine, you know, it was on the shelves. If shipping time was like 2 days. Fine, go start developing applications. I think since that time, there's so much demand for it. It got integrated into all major tier 1 data centers. You know, it's used to train language models, which are just so computationally intensive. They're just resource hungry. They eat up all the GPUs. You know, my gamer friends don't have any GPUs. Even my well-funded Silicon Valley startups don't have any GPUs. So what are you going to do? You're just completely blocked. And this is a way to unblock it. So it like crossed the pain threshold of being like so painful, so blocking, so much on the critical path that, you know, we just plow through barriers and we figured out a way through it.
So how did you convince your CEO to devote resources to, presumably when you folks started this was not 100% guaranteed to succeed,
We
right?
can hear both sides of this one.
Well,
Yeah.
yes, I mean, I think the compute story has been there. I think if I just think about historically how these models have been built, honestly, I think there's a huge reason why like we chose a transformer architecture and why that's taken off. And generally the path of deep learning, it's been led by hardware. So it's led in part because, and maybe in large part because we had the hardware there from gaming, from NVIDIA, and it could then be ported over to deep learning. And that's why it took off. Because otherwise, you know, deep learning was a highly skeptical field. You know, it needed scale in order to show real results. And so I think like hardware in many ways actually leads as a leading indicator of where this field will go and how this field has even like got to the point of where it is. Like it's possible that there's a better architecture that fits a better or different hardware that would actually perform better than what we have today. But this is what we have today. This is where we like, it's almost like a weird evolutionary, how do we evolve to the state? And this is how we evolved to the state. It might not be the optimal state, but it's a state. And I think that's why it's worth investing from the hardware perspective. And yeah, I guess based on scaling laws, which Greg co-invented many years ago now, with his team at Baidu, it was clear that, compute was going to be the limiting factor, or one of the big limiting factors, right? Data and compute to scaling these models to not only be larger, but to be more intelligent.
And so right now, if people want to use this AMD hardware for inference or fine tuning, it sounds like the best place to go is Lamini, right?
Sign up, it's free. Yeah.
Yeah,
And there's a free tier, supposedly.
Come on, Ben. I'm pretty sure you're on it.
So where is this work with AMD going? Is it going to other hardware providers like Intel also has a GPU? And then there's people who are starting to do CPU inference for LLMs. So Greg, if you were to make a prediction for the rest of 2024 beyond what you folks have done with this AMD and ROCm, what other things should people expect this year?
Oh, sure. I think it's a great question. I'm going to tell everyone what I've been telling them for 10 years, like software, invest in software. Hardware companies invest in software. This is the reason why it's difficult to port, from one to another. I think AMD listened to this, like to a greater extent than others, and has really been investing in ROCm and building out the software layer. From my perspective, I don't want to switch platforms. I'll switch platforms when I absolutely need to, when I'm fully blocked on it. I don't feel blocked on it in this, because now we have access to AMD. So I think we're actually, I wouldn't necessarily imagine you'll see everyone bringing this up really fast. I think software remains to be a hard problem, and it's an investment that only a very large company can make, like a large company with a lot of resources over a lot of time. It takes a while to build up to that 90%, so that someone smaller scale like us can cross over.
But for inference, Greg, inference on CPU seems like a lot of people are excited about. Is that
well, inference on CPUs are everywhere. So there's always the argument that CPUs are everywhere. And so probably there will be models that run everywhere. Now, language models are a little bit different. Like machine learning models in the past, we could usually get away with some classes of tiny ML. Tiny ML maybe it's recommendation, maybe it's, it's like the autocomplete in your search bar. Maybe it's
computer vision, what Sharon used to work on.
Yeah, maybe it's, you can embed it into glasses. Yeah. Yeah, those things probably can run anywhere. And so there'll be motivation to run them on the platform that's most pervasively accessible, which is a CPU. Language models, though, are really driven by scaling laws. So there is this benefit of having a much more powerful machine. So you'll have much better results if you have a much more powerful machine with language models. So I think that could actually make it a little bit different. I do think one trend that we haven't completely seen yet is tiny LLMs. I think Microsoft Phi is a good example of a darn good, for a billion parameter.
Or what about the work that took place in computer vision, sparsification, quantization? How far can you take that for LLMs so that you can run them on CPUs?
That technology has gotten substantially better. We have most language models now are even trained in, mixed precision, which we invented, by the way, but they're trained in a lower precision than even bfloat 16. They're now into float 8, and people are looking into extensions that go even lower than that, even for what people often use mixed precision, 8-bit, 32-bit, mixed precision. So there has been a trend of sparsification, low precision, just pushing down the energy requirements of running these language models. Now, the thing that's happened is that every single time that's happened, people have used it as a justification at the high end to run a bigger model.
Right.
Because of like the principle of scaling laws is a bigger model is going to just be a higher quality model.
By the way, a bit of fact checking, or maybe I'm wrong here, Sharon. But I thought scaling laws was the chinchilla paper from DeepMind. Now you're telling me it's Baidu.
Oh, it's a refinement. Go read our paper.
There are 3 papers. One, the first one, was actually Greg, and his
Okay.
team. And then the
I believe it. I believe it.
one
It's
was
called deep
OpenAI.
learning. It's scaling empirically.
Then there was OpenAI, and then Chinchilla was like, no, that's not true. And there's the Chinchilla.
Well, yeah, that's TLDR is right. A little bit more expansion around it is actually a research scientist named Jesse Engel. He noticed this scaling in one experiment in deep speech, which was a project in the Deep Speech 2 paper. There's one figure that shows a scaling law for speech recognition. The follow-on to that was I just didn't believe that it could possibly be true, that like physics would allow this to be true. And so we did a sweep over like 100 different machine learning applications and scenarios, and it was replicated in every single one. That was the deep learning scaling is predictable empirically. And then OpenAI really liked the idea of what it meant for language models. And so they published like language model scaling laws. And their conclusion was, well, you should have really big language models, like trillion parameter kind of like language models, like and then my friend Eric Elson, who just like really cares a lot about experimental methodology. He was also on like deep speech and Baidu in Chinchilla, and with a bunch of other, good DeepMind researchers. They said, well, it turns out that's not compute optimal. The really big model is not compute optimal. It should still be big, but it shouldn't be quite that big.
Right.
Yeah.
And so
All right.
now
So,
Llama's a little smaller than that.
so you folks, are a startup. Obviously, you're now working with companies and enterprises. So I wanted to, and I hope you have some revenue because I'm an investor. Full disclosure. Full disclosure to our listeners. But with that said, so let's take, what are your top 3 issues for enterprise adoption of LLMs? What do you think, what's blocking enterprises?
Yeah, one big blocker is expertise. So being able to have the right resources to actually build this stuff out. I think what's great about what we've built is that we've actually made it possible for existing engineering teams to actually be able to do this stuff with models, like do the things that OpenAI can do with these models. And that's exciting because I actually just got off a call with a customer today, and they said, you know what, I think we're actually just not going to hire a machine learning person.
So
Don't need 'em.
actually, Sharon, let me clarify this. So, what do you mean by what do they want to do? Do they want to train a model from scratch, pre-training, or fine-tuning, or inference?
It's anywhere from, inference, and these are like intense inference jobs, not necessarily small little.
And that's stuff for a regular enterprise, right?
Yep. And then so this is again working with open LLMs. So being able to work with open LLMs easily, both, from prompting and to fine tuning. And that's typically what we do. And then of course we have a few companies who are also taking it to the next level to pre-training. But first prompting with RAG, like RAG is a type of prompt engineering, and then fine tuning. So those are like 2 ways of getting expertise into the model, or also adapting the model and customizing the model, and being able to build differentiated models. Like these are like deeply differentiated models from their competitors that can actually not only stay the test of time, but also improve over time. Like be able to take in data from usage, from user data, and continually improve on that data.
So is it a security and governance issue? Because if I'm in an enterprise, right, so I can always use OpenAI API to just try things, and then maybe, because I guess the rule of thumb is if I can't get something good out of GPT-4, unless I know how to fine tune some llama model, then I'm unlikely to get something out of llama itself, right? So, 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 if I'm willing to do my pilot on OpenAI, then I don't need as much skill. But I guess once I prove out the pilot and I need to actually do more, maybe I need more. Is that kind of what you're describing here, Sharon? These are
Yeah.
people beyond kind of the pilot stage.
Yes, exactly. Production is what we're looking at. And yeah, people do transition from that, and it's like same teams transitioning from hacking prototypes on OpenAI to working on their own models.
And then as far as RAG, it seems like RAG itself is the hello world example for LLMs, right? So and it seems like it's actually deceptively simple in the sense that you can point an LLM to a bunch of PDF files, you get value. It's only when you realize that you may not get the maximum value by your naive RAG setup that you realize that you actually may need more help. But from the outset, you can probably build a simple RAG application, show it to some executive, is fund my project. See, we can get something out of this. Is that correct?
Yes, correct. Yes. I actually just taught the course on prompt engineering for open LLMs this morning on deep learning AI, Andrew's platform. And I went over RAG, and we went over, it was like 70 to 80 lines of open source code, and you could run it. It actually is pretty basic. And I think the thing I see is like people overcomplicating it or thinking it's really, really powerful, thinking it is AI. It's not AI, it's information retrieval. And it's been around for even longer than AI. Like Google has the best search, right? Information retrieval. So it's part of prompt engineering, actually. All you're doing is you're doing an automated search, like some kind of search functionality to be able to concatenate strings to more strings to your string, your prompt, right? So, and put that into the language model. So I think something that people don't understand fully is like, and I think they're starting to get to this. They're realizing, oh shoot, RAG is search, and it's not AI, nor is it software engineering. And so like it's this data, extra search piece, and it does give you benefits because it connects the LLM to the data a bit more because you can selectively choose which strings go into the context. But imagine if your prompt was infinite. Like imagine if you could actually put all of that data into the model in some way. That's what the next step gets you. So that's what the next step of like fine tuning gets you. It's like, actually, let's just put everything in. And then actually when you put everything in, maybe even when you put everything in, like something that's kind of counterintuitive that I find kind of magical for people is they're able to kind of ask questions across different documents, for example. And it's able to actually answer correctly. And I think that there are moments like that are very magical, or like reduce hallucinations. Be able to actually add similar guardrails as OpenAI can for like, as an AI model, I can't answer that, like being able to add those guardrails as well. And so I think it's been just like really interesting to see people evolve over time in their usage and kind of like the different bits of magic that they see.
But so are you saying to some extent, so as you say, RAG is information retrieval, and that means that there's certain knobs you have to tune, right? So like what's my information extraction strategy, right? So if it's a bunch of PDF files, which of the 30 PDF extraction libraries from Python should I use? Or which OCR library should I use? Which web crawler should I use? And then chunking, and then embedding, and then which search and re-ranking. So there's a lot of knobs for a regular enterprise might be complicated to find the right set of parameters for the RAG setup, right?
All those things are true that you do end up like you can twiddle with the parameters. If you look at search benchmarks, though, the twiddling with the parameters doesn't usually move the metrics that much. Like search benchmarks usually don't, and it's just search. It's the needle in the haystack. Imagine Google, like, the I'm feeling lucky. Like every single, like what would 100% accuracy be? It would be like every single time you press the I'm feeling lucky button, it like out of a billion documents on the web, it's like exactly the right thing. Like it's just such a hard problem that like the technology has advanced a lot, but don't expect like an order of magnitude jump from like fiddling with knobs. Like you're not going to be able to, Google can't fiddle with their knobs and get like I'm feeling lucky to hit every single example.
But I guess the main thing is you have to have the right data. Just like Google might be a better search engine because they have the best index. So if you have the right domain specific data, so it's like everything goes back to
Data.
focus on the data. I mean, I do a lot of I do a lot of fine tuning using any scale service, and I don't actually do any fine tuning. I just spend all my time on my fine tuning data.
Yeah, exactly.
Um,
Exactly.
and so I wish there were better tools to help me kind of, inspect and create this fine tuning data sets, right? So
Oh, that's a really interesting topic. Actually, one of the use cases that we've seen people like move on to is, well, now we have language models. Language models are very powerful tools. You can prompt engineer them, you can ask them to do tasks you could ask a person to do. So why not ask the language model to read all of your 10 million documents
Transform it.
and transform it, into a better format? We see people doing that. And actually, one of the most interesting things to me, again, from a computational perspective, we had one customer want to do this with it was 50 million documents. They want to do it on one GPU. It would take them 3 years, to run Llama.
right.
But well, that's a great opportunity to run that on a 400 GPU cluster. It'll just take minutes.
Right. So Sharon, so they still need people. So what kind of people do they need if they're using Lamini? Software engineers or? So they
Yeah.
don't need, you're saying they don't need deep ML experts.
They don't need top AI PhDs like ourselves or folks at OpenAI. Yeah. I think this helps, a couple things. Like one is definitely accelerating development. Of course, like you can always hire another person like that, but I think accelerating development is really key. And it's also why we're so focused on software engineers is that they can also deploy in production. So like folks who actually, this is
Unlike data scientists and ML people.
Oh no. Yeah, no, kind of seriously, yeah, unfortunately.
Yeah.
But like historically ML has been like this weird, no man's zone between R&D and production. And for a long time it was only in R&D, right? Just research. But now it's actually starting to hit production loads and starting to like just shift. That shift happening means that one, you could have a separate ML team and hand it off to your production engineering team. You still need to do that, right? Like that's what GitHub Copilot, how that was built. Like GitHub's team grabbed it from OpenAI, and there was, a lot of, if you read the news or anything, there's a lot of communication friction, obviously, between those teams. And so why not just have one team do it? And I think we're at a point where the technology's there for one team to do it. And I actually can see this team doing it faster. So
do you folks find so do people know how to identify the right use cases? So in other words, people know the technology well enough since they play around with ChatGPT. They kind of know the strengths and limitations. So you don't need to suggest use cases. They come to you with use cases, and the use cases seem to be right on target, or what?
yeah, this has been such a fascinating learning curve. So if you asked me the same question 6 to 9 months ago, I'd say absolutely not.
Yeah.
I would say no. But I think now, yes, people are coming to us with good use cases in mind, and they have a sense of what these models can and cannot do. They still need some expertise in terms of scoping it out and understanding the limits of ROI basically, and like, hey, I want to do it in this time frame. How long does it take? I think that still requires some understanding. But I don't. Yeah, I actually see a surplus in use cases, a flourishing of use cases, and people are even saying, we have too many use cases. Which one do we even prioritize within our organization? So it's been really exciting. I think people are really, really creative, and also just when you understand your own domain, you understand the problems in that domain, and you can probably solve for them. You can solve for all of them. And so it's really exciting to see a lot of the different use cases out there. But yes, we do help with prioritization. We do help with, given our understanding of how difficult certain things are to pull off versus others, and kind of what ROI and performance that they would expect from it to get ROI. I think I think those are all factors. But that's starting to get into like regular product as well. Yeah.
So in terms of privacy, security, and governance, so obviously some people will be comfortable for certain use cases just using some public endpoint or public API. Some people will want to go on-prem. So what's your sense of what what do you think the percentage of people wanting to do it all on their compute clusters versus those who are comfortable using a public endpoint versus those even comfortable doing everything on the cloud, but they control it, right? So private cloud kind of.
We're seeing a mix of things, and actually some people do multiple of those things, to be
Okay.
honest. It depends on the data. It really depends on like where the data has been living. I think that's one big part. And of course, just like access across the organization, and which if engineers are going to be using this, like how are they going to be using this? What access did they have before? So we are seeing that across different things, and that's why we built Lamini essentially to be agnostic. And so we pass every enterprise security review, including running without the internet on. So like, yes, you can install it anywhere and it'll run. And so I think that's been an important piece of our journey, and also understanding our customers' pains of, hey, I want an LLM, but I don't want to mess it up. I really just don't want to mess it up. I don't want to mess up, leaking all my data and getting this like insane, extraordinary penalty from the government. I don't want to, do all these, leaking PII, for example. So I don't want to mess it up. I've learned and built out a really clear data governance, path and structure so far. And I don't want LLMs and the hype of it to just like destroy that entirely. And so we're here to say, hey, we're the safe option. We're going to make this possible for you, easy for you. And we're going to pass your security review because we've passed probably the most stringent ones. And so, yeah, I think that's one of our value props. But yeah, I think people are doing it on diverse sets of environments.
So the hello world #2 example in this space.
Yeah.
I don't know if this is happening in enterprise, but I know that, someone does RAG first, and then the next thing they try is function calling, right?
Oh, yeah.
Yeah.
So is function calling a thing in enterprises? Not yet. Too early.
It absolutely is. What I take this, like the way
So
I
give me some use cases. Give me some examples of what they're using it for.
well, I'm interacting with a user, and the user is, telling me some information about them or what they want to do. And then maybe I want to store it in a database, or maybe I want to, take an action, like schedule something on a calendar, something like that, or call another system. It's just the integration. I think of this as the software engineer. It's the language model is not an application. It's like embedded inside of an application. And
No, but so you're saying that some enterprises are already on this path.
yeah, I can't think of one that isn't.
Okay.
That I've seen. So you do the prototype with an open model, you do some prompt engineering. I actually think that's the superpower of language models, like why these use cases are so much more prolific, as Sharon was saying, than deep learning. I did a lot of deep learning solutions over the last 10 years. Yeah. You have this thing of like just any software engineer can like import the model and just call an API, and then they get something and it's pretty good. And then they can tweak it a little bit with prompt engineering. So they can build that prototype. They can add RAG. You can do all this stuff in an afternoon, right? Like
Yeah. No, I describe where we're at. We're in the product hunt era of AI. So the people who build for product hunt are the ones building AI apps now,
Yes.
So if you go to product hunt, there's so much AI things on there now, right? So
Yeah, so you've got to call a function. And then what usually happens is, well, the language model, remember, it's string in, string out. So I got to figure out some way of getting that string into a function, like which function is it going to be? And then how do I get the string output into the parameters of the function? And so you end up like writing a parser, or you end up doing some like prompt engineering. And then hopefully the language model spits out something that's parsable, but then you have to handle all the cases where it doesn't. And like you just end up with all this like really annoying, ugly stuff. So we saw that use case like so many times. We spent 3 months. We got some PhDs in programming systems. We basically completely ripped open the decoder of the language model, and we integrated it's like a grammar, like a normal kind of grammar you'd see in like a programming language, and said, okay, language model, you have to conform to the grammar.
So Sharon, what do you think what keeps you up at night, not as a startup founder, but just looking at this space in general, what can derail or slow down adoption?
Oh, definitely access to compute that runs these models. Yeah, 100%. And that's why our partnership, just looking all the way back, it means so much. And I think like the second thing would be the expertise piece. So like that's why we're bridging that gap, and that's why we're servicing the customers we are. And then the third thing, like the real thing that keeps me up at night, is probably I just got Invisalign. So you wanted to know, Ben. You wanted to.
But you're not wearing it
I'm
right
not
now.
wearing it now for you, for all you viewers and listeners who want to hear my S's.
So Greg, one of the things that worries me, I don't know if maybe I'm overly concerned about this, is the open source LLMs, right? So right now the number of suppliers really comes down to a handful of companies, right? So what if they change the license, right? So what if one of the proprietary LLM providers, I don't know, DeepMind, OpenAI, have a breakthrough? And remember, the Transformers people, they published that, but now they may not publish things anymore. They might just say, hey, we had a breakthrough and you can try it. It's amazing, but we're not going to tell you how we did it. So
First
then
of all-
how does the open source LLM community keep up, right? So there's two questions there. One is we have few suppliers, and then secondly, can the open source LLMs really keep up with the proprietary LLMs?
I think there's a motivation to keep the open source LLMs up to date with the proprietary LLMs. I think you see Meta doing this, very prominently. I think you probably see others doing it.
So you're not worried that they're going to change the license?
Here's the counter for the fear of like, okay, someone going all proprietary. It's basically like the collective weight of all of the enterprises who don't like the idea of all of the data in the world getting like sucked up into someone else's model, and then them getting to dictate, a monopoly on it, like charge everyone else for it. Like you're in data, Ben. Like I think, remember, the history of data is like, it's not to put all of the proprietary, data lake, data warehouse on the internet so that your competitors can use it against you. Like I think it's just that whole idea of like all of the data in the world like ending up in one model somewhere is just like, we've been through this before. We've learned that lesson. Like the industry has learned that lesson. I don't think the community is going to let that happen. Someone's going to stop that from happening.
Well, right now we do have only two or three suppliers of competitive open source LLMs, right? So Meta, maybe Mistral, Falcon, no one uses, right? So
Clear, like I know Transformers was like the paper that seemed like the turning point, because people want to point to one thing and it helps. But
no, I'm just saying that that's just an example, right? So
at the time, there's so many people working on it, like this same architecture. I think we could have just found another one if that didn't happen. But yeah, I actually find it kind of interesting that the major models out there are actually not by anyone from the Transformers paper.
yeah, I guess the counter to that is everyone lives in the Bay Area and they all go to the same parties. So it's not like they don't talk to each other, right?
Let's wait number 32 on OpenAI. Oh, you didn't know it's 0.5? Oh no. Yeah, pretty much that. Yeah.
So are you folks hearing from enterprises about multimodal models? No.
Definitely starting to hear it. I think definitely the moment OpenAI has released that on ChatGPT, I think that helps people's imaginations a little bit more.
But then again, at that point, we have to wait for someone to release an open source.
I think I know who's working on it.
Equivalent, right?
Yeah, I think I know who's working on that. Yeah.
Okay.
A good one. Yeah.
Interesting.
There's some, yeah.
And so any particular trend that you folks are particularly following this year, 2024, in this space, that you think people are not paying enough attention to?
What is something no one's paying attention to? My God. I believe there are eyeballs on everything right now.
Yeah.
But I am very bullish on open source. I actually think the gap has been closing pretty substantially, actually. So it's been a pretty substantial closing, and I think just recognizing that and looking back at that, remember how far it was a year ago, is Pythia, which, you know, love
I
it,
remember
Loser
that.
AI,
Yeah.
incredible that a nonprofit was leading the charge, like, for the honestly longest time ever. But you know, it like Llama to Mistral, like these are so much better than
Again, only two companies. We're completely dependent on these two companies.
I
Yeah,
don't
there
think
were-
that's true, Ben. Like, I think if you look at what's like the leaderboards and like the open source community, I think that there are so many people throwing their hat into the ring. And
Yeah.
like what we end up doing is we just talk about the particular winner, like the one
Okay.
who is at the
Or
particular
with the
time.
largest marketing team, for example. It's not actually the leaderboard winner. Like they're not actually leaderboard winners, I'm pretty sure. Like I'm pretty sure people find
Or they end up because they're in the leaderboard or they have the marketing team, all the endpoints put them on their service, so then everyone uses them. So everyone thinks that, okay, so this must be the one to use because everyone has it available, right?
Yeah, otherwise it's too hard to keep track of, honestly. And so like I think I mean it's not just marketing, it's obviously very good science and a lot of money poured into it. It's just yeah, I wouldn't say that plays no part at all. There's a reason why it is the ones that are the loudest that are being used.
Yeah, on my end, I feel like there's not enough startups working on the data piece of LLMs. You know, just like several years ago, 5 years ago, we had this generation of data engineering startups that were, you know, targeting lake houses and warehouses. There's no such set of cohort of startups for LLM data. There's maybe a few companies, but most LLM companies like yourself are not working on it. Not that I want you guys to work on it, but
We actually are working on it in terms of like
Yeah.
but it's very deeply tied with the compute.
with your stack.
Yeah, it's very, very deep. And it's also very, very much tied to like compute infrastructure. So I think like it can be hard to be a standalone, oh, we're an LLM data startup, but we also don't have giant access to compute. I actually think that can be challenging.
Yeah, I think it's important to remember, like language models are so computationally expensive, right? 7 billion parameter model is like pretty popular. That's 7 billion floating point operations per token,
Mhm.
like per word.
Yeah.
Imagine using that to process all of your data.
Yeah, no, that's why I tell enterprises don't bother trying to deploy yourself. You know, because you might think it's easy, but when you look at the details, it just becomes, assuming that whatever it is that you're building gains any sort of usage or traction, then it becomes a nightmare for you to try to deploy this on your own.
I usually tell them, how about you try it first? And then I get a call back.
Yeah. I guess, Greg, my thing with the data piece is that my sense is because data is so important that a lot of the knowledge about data is with the domain experts who are not actually programmers. So if we just had the right tools so that they can help, you know, create the fine-tuning data sets or refine the prompts or whatever, right? So then I think a lot of companies will end up having even more performant, more accurate, more tuned models.
I think that's completely true. And it's been difficult in the past to do that because the tools that we would use to process the data, maybe you'd need, you know, again, like a data engineer, or maybe you'd even need a machine learning engineer. Maybe you want to build a filter or a classifier. And so you have to do some machine learning. It's hard to teach that to a domain expert. One of the things I do think changed here is that we have zero shot. We have LLMs. If you can write a sentence in English, you can write a data pipeline stage.
But everyone I talk to around here, they get excited about JSON. Come on, man. The civilians don't understand JSON.
Okay, there are different tiers of civilians talking about here. But fair, they know Jason, like the guy's name, you
Yeah.
know?
Yeah.
So
Yeah.
But yeah. So anyway, so with that, thank you, Sharon and Greg. And for our listeners, you can check out what they're doing at Lamini.ai.